And welcome back, everybody. My name is Mr. Owings. We are working in Ozaria for JavaScript. We are on Chapter 2, Module 4, and we're working on the episode Narrow Streets. Those cards just keep getting in the way. Let's see how we can tackle this. Okay. Start the code to check to see if the path is free. Now add a conditional. You can check the code bank. So if we look at our code bank, and I'm going to probably do this pretty much the whole time. So we're going to check hero can move right. So can move right. And the reason I'm doing this is because I want you guys to see both be familiar with documentation. There's an old joke that sometimes 6 hours of debugging can save you 5 minutes of reading documentation. It's not a bad idea to read the documentation whenever you're using a system, but there will be things you want to understand, and I'm going to try and explain some of the things we see here. So what we're creating is a variable, and we're using a function in this method, which is part of the hero object. The method uses something very unique. It's called a return. And a return is going to effectively be what this is going to equal. So if it returns an integer, it'll be an integer. If it returns let's say a name, so if it returns a string, then the string will be here. In this case, it returns a boolean. A boolean is two results. Bool, and sometimes this referred to as a bool in other language, bool. It will only have two results, and those two results are true or false. So in this case, path free will be equal to true or false. So he's going to check and see if that cart blocks his path. And one of the ways we can check that, I think, if we do hero.say and then we make him say path free. And this is only a test. If it doesn't work, it doesn't work. But he should say true. Yeah. So he is actually returning the variable. And I assume because it's very similar to console.log. So now it's false. Great. So a conditional only checks to see if your variable is true. And there's two ways you can write this conditional. So multiple ways you can write this conditional, but the two main ways you'd be looking at is if path free is equal to true. That will return true. True is true. That's all we're asking. Is true true? Now, the other cool way you can write this is because if you've used algebra and you've learned substitution method, this will make a little more sense. Just like a variable with substitution method, you can just put the answer there. In this case, when that returns true, we can put that here. And if path free is true, it just says true. So that's one little hack you can learn. It's a little more advanced than some of you probably are right now, but it kind of makes sense, right? It's only true or false. So if it's true, what are we going to do? Well, we're going to move right because he can move right. And we should set that to 2. And then we're going to move up, right? Because he can move up. We're going to set that to 2. All right. So path free is true. Now, I want to show you another cool little hack. This is something that is interesting. There's another form of writing this. So we can say is path free equal to false, which we'll define as true because false is false. We can say we can use this really cool, and I think they do teach this later in Ozaria, but I'm going to teach it now because I think you're capable. So is not true. So true. So this will define as true because the exclamation point you can think of as the word not. So is path free not equal to true? Well, false is not equal to true, right? So that's going to trigger on path free equals to false. Another cool way you can think of it, if we're using the not, just like that will return to true, we can say if path free is not true. So false is not true. So true is true and false is not true. And that is going to check for false. So that's a neat little hack. If it's too confusing, use the other methods. Use the equals false. That's fine. totally viable method. But if you want to learn kind of a cool shorthand that is totally legitimate, and every programmer would recognize that as checking for not true. So you can scratch that little back and get your little programming wizardry on and feel pretty awesome. So if not true, so if he can't move right, then we want to move up, right? How we write the if statement isn't as important as having the good logic. Then we want to move right. And these are both going to be set to 2 because he's going to move up and then he's going to move right. Perfect. Makes sense. We're going to get to that other totem. Let's close this. What do we need to do? Then we need to move up and we need to move right because that's going to happen either way. So that's going to finish it, right? We have all of our check marks. He checks to see if it's true. It's true. So he's going to move right and then move up. If we run it this way, he's going to go up, not true. So we're going to move up and then move right. So if this was helpful to you, go and give this a like. If you think that hack was worth learning, why don't you tell me about it in the comments? I like learning that you guys are finding out you guys are learning new and exciting ways of programming. It's a cool field, and I wouldn't have been a programmer for 7 years if I didn't love it. All right, so you guys have a great day. I'll catch you in the next one.